Hello, good people. Welcome to video number 4. We're supposed to do example 3 as another example of implicit differentiation using this. I call it a recipe because it gives me the steps of what I need to do in order to get to what I want, right? Kind of like when you're cooking, you follow the steps and you get what you want. Here, we're going to follow these 4 steps and find our dy dx formula. But before I do that, I do want to go back because I think it's important for us to see what's going on. And so I'm going to go back to number 2. And what I've done is I've graphed number 2 in Desmos so that we can see what exactly does y squared plus 2xy minus x to the third equals 4 looks like. Because I think you're going to find it to be pretty interesting. So when I go to Desmos, and I'm about to go to Desmos now, this is the graph that we get. Notice this graph is not a function. It doesn't pass the vertical line test, but it is a graph and it is created by that equation. And at any given point, we can find the slope of that point. For example, if I find the y-intercept here, my y-intercept, it actually has two y-intercepts. One of them is at 0, 2, and the other one over here is at 0, negative 2. But just to show you what we're doing, we're finding the slope of the tangent line with that formula that we found in the previous video in example 2. When I look at the tangent line here, I can tell that my derivative, my dy dx value at this point, 0, 2, has to be negative because my graph is going down. So I know that my derivative is negative. But what I'm going to do is I'm going to take my x0, my y2, I'm going to come back to my formula. And if I come back to my formula, I'm going to use that formula to say dy dx, the derivative of y with respect to x, at x, actually not x, at 0 comma 2, because I need my x and my y values, is negative 2 times my y value plus 3 times my x value, all divided by 2 times my y value plus 1. And if I do the math here, well, this is going to go away because I'm multiplying by 0. So I'm left with negative 4 over, and then this is going to be 2 times 2, 4 plus 1 is 5. My slope is negative 4 fifths. And if you recall, if I go back to my graph, we said the slope had to be negative because at this point, the tangent line is pointing down. So the purple formula we found in example 2 will find the slope at any one of these points that are highlighted, and even at the points that aren't highlighted. It'll find the derivative, the slope of the tangent line, at any of these points. And we get to see more interesting graphs because we see that now with implicitly written equations, we can make some pretty non-traditional, I put it, non-traditional graphs because they don't have to be functions, right? So let me go back and zoom out, and we are going to do number 3. We're going to follow the 4 steps. Step 1, take the derivative of both sides. So I'm going to take the derivative, and by the way, I'm writing this. You don't have to, but I'm writing it so that I can be very careful and make sure that I'm doing all the steps that I need to do. I'm going to take the derivative of the left side, which has 3 terms, so I'm writing them separately in order to find the derivative of each term and then put them back together. And I'm going to take the derivative of the right side. So the derivative of the right side is pretty easy. The derivative of the right side would just be 0 because the derivative of 0 is 0. When I go to find the derivative of the first part, I notice that my expression is in terms of x. My variable of differentiation is x. So therefore, the derivative of x cubed is just 3x squared. Minus. When I look at this middle term, it has x's and y's. So technically, there are 2 different functions. And because there are 2 different functions, I'm going to need to do the product rule. The product rule says take the derivative of the first, take the derivative of x, which is 1, times the second, which is y, plus take the derivative of the second, which is 1 times dy dx, not dy dy, dy over dx, times the first, which is x. So there was one term, but because I was multiplying x's and y's, I had to do the product rule, and it created two terms, each of which is being subtracted by that minus sign. Plus, take the derivative of y cubed, but I'm taking the derivative with respect to x, so this is going to be 3y squared times dy dx. And I've stopped. I'm done with step number one. Step number two says, all right, move everything that doesn't have a dy dx to the other side, and keep everything that does have a dy dx on one side. Well, this doesn't have a dy dx, so it's going to go over. I got to be careful here because I'm subtracting 1y. So I'm subtracting 1y, but I'm also subtracting this. So I'm going to, at this point, take away the brackets, but I need to give away the minus. And maybe I should have done that before I started step two. There were two things inside the brackets. We were subtracting both of them, so I have to minus this, and I have to minus that. Keep whatever has a dy dx. Okay, I'm going to keep this one, and I'm going to keep this one. But everything else, I'm going to have to move to the other side. So I'm going to move this 3x squared to the other side by subtraction, and I'm going to move this minus 1y to the other side by addition, and I'm left with this. I have now separated my terms into left side with dy dx, right side without dy dx. All right, let's go to step number three. Step number three says factor out a dy dx. Well, the only terms that are left on the left side have a dy dx, so I can do that. If you don't want to write the 1, you can just say minus x or negative x. And then on the other side, that stays the same because there is no dy dx to factor out. Also, if you want to just write a plus y, not a plus 1y, you can do that as well. Great. Now the last step is divide both sides. I'm trying to get dy dx by itself. So divide both sides by the parenthetical expression. Whatever's inside the parentheses, you're going to divide both sides by. So dy over dx is whatever was on the right side divided by whatever I was multiplying times dy dx, and I'm done. This is the formula. This is the equation for the derivative of y with respect to x of this equation that we started with. An equation that's written implicitly because it mixes my x's and y's. I don't know. Explicitly means I can clearly see that y equals something or that x equals something. Here, I don't know what y equals. I don't know what x equals because everything's mixed up. But implicitly, we can find the derivative and get a formula. Again, notice the formula has x's and y's. So I'm going to need an x coordinate and a y coordinate to figure out the slope. This is implicit differentiation, or as students usually tell me, this is the part of calculus where I'm going to have to use like a whole page to write down my work. Maybe. I just need you to be careful when you do these 4 steps.